In this lesson, we are going to learn how to use various factoring techniques to solve a polynomial equation. Even though factor theorem will work on any polynomial, it may not be the most efficient method. Therefore, we often try to use different factoring techniques first, such as common factoring, factor by groupings, and change a variable, before we use factor theorem to solve. In the following examples, I will show you how to use the various factoring techniques to solve a polynomial equation efficiently. Example 1. Given a polynomial equation, first we notice there are 4 terms, so let's put them into groups to see whether or not there's any pattern in the coefficient. If I group those 2 terms together, I can see the coefficient is 1 and -1. If I put those 2 together, if I factor out a -9, then I can see the coefficients are 1 and -1, which means they have the same coefficients. Therefore, I know this question can be factored by grouping. That's factor by grouping now. First, I put a bracket around the first 2 terms. Next, I put a bracket around the next 2 terms. And I'm going to put addition sign in between those 2 brackets, means the first group plus the second group equals 0. Next, let's common factor each group. For the first group, they have x squared in common. So we factor out the x squared, and then we do x cubed divided by x squared, which is x. And you do negative x squared divided by x squared, you get -1. And you look at the second group now. They have a -9 in common. So we factor out -9, and you do -9x divided by -9, you get positive 1x. And positive 9 divided by -9, you get -1, equals 0. Now, look at the 2 terms that we have. They have x minus 1 in common. So we're going to do common factoring again. We factor out the x minus 1, and let's look at what's left on the first term. So if we take out x minus 1, that means we have x squared left. And for the second term, if I factor out the x minus 1, you have -9 left. Close bracket equals 0. If you look at the green bracket closely, you can see this is difference of squares. That means I can use difference of squares factoring method to factor this green bracket into x plus 3 times by x minus 3 equals 0. Once we have all the linear factors, then we can solve for x now. So we know x minus 1 equal to 0, or x plus 3 equal to 0, or x minus 3 equal to 0, which means x could be 1, or x could be -3, or x could be 3. Therefore, we make a conclusion. X is an element of a set of 3 values, -3, 1, and 3. Method 2. We're going to solve this polynomial equation again, but this time, we're going to use the factor theorem to factor it. First, let's define our PQ values. P is the constant term, and Q is the leading coefficient, which is a 1. Then we have to find factors of P, which is positive -1 and positive -9, and Q will be positive -1. Now we're going to find all the possible values, P over Q. So we do 1 divided by 1, which is positive -1, and we do 9 divided by 1, which is positive -9. Then we substitute those 4 values into the function to see which one can give us a 0. So we try fi1 first, and which is a 0, then we know x minus 1 is a factor. Once we get a factor, then we use syntactic division to divide it. As you can see, our quotient will become x squared minus 9. So we can rewrite this equation into the factor form. How do I write it? First, we write down the divisor. Next, we write down the quotient, x squared minus 9 equals 0. Once again, this is a difference of squares, so we're going to factor the purple bracket into 2 other brackets. X minus 3 times by x plus 3 equals 0. Now we can solve for x. So we know x minus 1 equal to 0, or x minus 3 equal to 0, or x plus 3 equal to 0, which means x could be 1, or 3, or -3. And then you make a conclusion. X is element of a set of 3 values, -3, 1, and 3. Example 2. In order to solve a polynomial equation, we need to make sure on the right-hand side of the equation is a 0. So we have to subtract 5 on both sides to get a 0 on the right of the equation. Since this is not a quadratic trinomial, therefore we have to use factor theorem to factor it. So first, let's define our p-value, which is a constant term, -5. Then we define our q-value, which is the leading coefficient 1. Then we find the factors of p, and we find the factors of q. Now we're going to find all the possible values for the factors p over q. Now, let's define the left-hand side of the equation is our fx, and we're going to substitute those 4 values into fx to see which one can give us a 0. So we try f at 1, which is a 0. That means we got our first factor already. X minus 1 is a factor. Then we use synthetic division to divide it to find the quotient. That's the synthetic division. First, we write down the division symbol. Next, we have to write down the coefficient of the dividend. So we know we have a 1x cubed, but right now there's no x squared, so we have to fill in a 0. 0x squared plus 4x minus 5. And we put the divisor on the left-hand side. -1 will become a +1. And then we can do our division. So bring down the 1 first. And 1 times by 1 will give you a 1. We add those two numbers up, you get a 1. And 1 times by 1 again, you get another 1. 4 plus 1, you get a 5. And 5 times by 1, you get a 5. Now we know the remainder is 0. So from the equation, x cubed plus 4x minus 5, I can factor down to the divisor, x minus 1 times by the quotient, x squared plus x plus 5 equals 0. Now, let's see whether or not this quadratic trinomial can be factored down further. So we use the discriminant to check b squared minus 4ac. As you can see, the value is actually -19. That's not a perfect square. Therefore, this trinomial cannot be factored down further. Since we know this polynomial equation cannot be factored down further, therefore we do solving directly. So we say x minus 1 equals 0. That means x could be 1, or x squared plus x plus 5 equals 0. Then we use the quadratic formula to solve for x. After we substitute the values in, we will see we have -1 plus or minus square root of -19 divided by 2. So square root of -19 can be broken down into 2 square roots. Square root of 19 times by square root of -1. And we know square root of -1, which is our imaginary number, I. So we are going to rewrite it as square root of 19i. Therefore, x is element of a set of 3 numbers, 2 complex roots and 1 real root. Let's do a different scenario. Instead of looking for x such that x is element of complex numbers, now we're going to say we are finding x such that x is element of real. Then those 2 imaginary roots will not be accepted. Therefore, x can only be 1. Example 3. Now we see there are 3 terms in an equation, and exponent of the second term is half of the exponent of the first term. So we know this could be a quadratic in disguise. Now, let's use the discriminant to check whether or not this trinomial can be factored down further. So, as we can see, the values turns out to be 676, which is a perfect square, 26 squares. Therefore, we know this trinomial can be factored. Moving on to the factoring. First, let's draw a cross. Second, we want to get x to the power 4 on the left and -25 on the right. So think about 2 terms that multiply to x to the power 4. We know it has to be x squared times by x squared. And think about 2 numbers that multiply to -25. It has to be -25 and +1. Now we will do a cross multiplication to make sure that we have the same middle term as -24x squared. So when we cross multiply, we get 1 times by x squared, 1x squared. And -25 times by x squared, -25x squared. When we add them up, we get negative 424x squared, so which is matching our equation. Therefore, we know this is our factor. Our factors are x squared minus 25 and x squared plus 1. As you can see in the first bracket, there is a difference of squares, so we can factor it into x plus 5 times by x minus 5 times by x squared plus 1 equals 0. Now we are ready to do the solving. So we know x minus 5 equals 0 means x equals 5, or x plus 5 equals 0 means x equals negative 5, or x squared plus 1 equals 0 means x squared equals negative 1. We have to remove the square, so we have to do square root on both sides, but remember we have to put a positive negative sign in front of it. So we say x equals to positive negative square root of negative 1, and we know square root of negative 1 is our imaginary I, so we say x equals to positive negative I. Therefore, x is an element of 4 numbers, positive negative I and positive negative 5. 2 are complex numbers and 2 are real roots. Therefore, we say x is element of a set of 4. Therefore, x can be positive negative I or positive negative 5. 2 are complex roots and 2 are real roots. On the side note, if we are looking for x such that x is element of real, then we will not accept imaginary roots as our solutions. Then we will say x is element of positive negative 5. Example 4. As you can see from this polynomial equation, we do see they have something in common, x squared minus 5x and x squared minus 5x. So this time, we're going to use a different technique that is called change of variable. Now, let's replace x squared minus 5x with a w. So I can rewrite the equation as w minus 5 times by w plus 3 equals to 9. Since we are solving for a polynomial equation, we need to make sure on the right-hand side is 0, so we have to subtract 9 on both sides. Before we can do that, let's expand and simplify the left-hand side before we combine the 9. So after we expand the left-hand side and we subtract 9 on both sides, simplified it, we get w squared minus 2w minus 24 equals 0. Once we have a quadratic trinomial, let's try to factor them on the side. So we have w squared minus 2w minus 24. Let's do a cross. On the left-hand side, we want to get w squared. On the right-hand side, we want to get negative 24. 2 terms multiply to w squared. It has to be w times by w. 2 numbers multiply to negative 24. We can try negative 6 and 4. When we do a cross multiplication, we do w times by 4 plus negative 6 times by w. We'll get negative 2w, which matches our middle term. So we know w minus 6 is the first bracket, and w plus 4 is the second factor, equals 0. Once we have the linear factors, then we can substitute x squared minus 5x into w again. So we're going to get x squared minus 5x minus 6 times by x squared minus 5x plus 4 equals 0. Now we see 2 other quadratic trinomials. Then we're going to try to factor each one of them. So first one, we're going to factor x squared minus 5x minus 6. We do a cross. On the left, we want to get x squared. On the right, we want to get negative 6. 2 terms multiplied to x squared must be x times by x. 2 numbers multiplied to negative 6, we're going to try negative 6 times by 1. Let's do a cross multiplication in the middle and add them up. So we're going to get negative 5x, which matches our middle term for the first bracket. Therefore, we can read the factors are x minus 6 times by x plus 1. Next, let's try to factor the other quadratic trinomial, x squared minus 5x plus 4. So on the left-hand side, we want to get x squared. On the right-hand side, we want to get positive 4. 2 terms multiplied to x squared has to be x times by x. And 2 numbers multiplied to positive 4. Since the middle term is negative, so we're going to try negative 4 and negative 1. Let's do a cross multiplication in the middle and add them up. We're going to get negative 5x, which matches our middle term here. Therefore, we know this quadratic trinomial can be factored to x minus 4 times by x minus 1 equals 0. Now we are ready to solve for x. So we know x minus 6 equals to 0 means x could be 6, or x plus 1 equals 0. That means x can be negative 1, or x minus 4 can be 0 means x can be 4, or x minus 1 equals 0 means x can be 1. Therefore, x is an element of a set of 4 numbers, positive, negative 1, 4, and 6. Example 5. This equation is another quadratic in disguise. As we can see, the exponent for the middle term is half of the exponent of the first term. We are going to replace x to the power 1 over 3 with a w. Then we're going to square both sides. When we square both sides, we're going to have a power to a power. We multiply the exponent. So we get w squared equals to x to the power 2 over 3. So we can rewrite the equation as 6 w squared plus 5 times by w minus 4 equals 0. Now that we have a quadratic trinomial, we're going to try to factor it. So on the left-hand side, we want to get 6w squared. On the right-hand side, we want to get negative 4. So we want to find two terms multiplied to 6w squared. So it will be 3w times by 2w. Find two numbers multiplied to negative 4. We're going to try positive 4 times by negative 1. Let's do a cross multiplication to see whether or not we can have a middle term of 5w. So 3w times by negative 1, we get negative 3w. 4 times by 2w, we get positive 8w. Add them up together, we get 5w, which is our middle term. So we know 3w plus 4 is the first factor, and 2w minus 1 is the next factor, equals 0. From this equation now, we can say 3w plus 4 equals 0, or 2w minus 1 has to be 0. That means 3w equals negative 4, and w equals negative 4 over 3. Or 2w equals 1, then w equals 1 over 2. Now it's time to replace w back into x to the power 1 over 3. Once we substitute the x back, we also need to remove the exponent 1 over 3. So we have to cube on both sides for both the equations. Then we will have x equals to negative 64 over 27, or x equals to 1 over 8. Example 6, we are solving an equation with radicals. The first thing we have to do is to rewrite the equation into exponential form. And after that, we need to have a 0 on the right-hand side of the equation. So we subtract 3 on both sides to get a 0 on the right-hand side. Then we can see this is not a quadratic in disguise, as the exponent of the second term is half of the exponent of the first term. So we are going to replace w to the power 1 over 4 with a variable k. Square both sides of this equation, we get k squared equals to w to the power 1 over 2. Now we can rewrite the equation into k squared minus 2k minus 3 equals 0. Now that we have a quadratic trinomial as an equation, then we're going to try to factor it. So left-hand side we want to get k squared, right-hand side we want to get negative 3. Find two terms multiplied to k squared, we get k times by k. Find two numbers multiplied to negative 3, we find negative 3 and 1. That's cross multiply to see whether or not we can get a middle term of negative 2k. So k times by 1 is k. Negative 3 times by k will be minus 3k. And adding up together, we get negative 2k, which is our middle term. So we know this quadratic equation can be factored into k minus 3 times by k plus 1 equals 0. Now let's solve for k. So we know k minus 3 could be 0, means k could be 3. Or k plus 1 could be 0, k could be negative 1. Now let's substitute w to the power 1 over 4 back into k. Let's raise each side of the equation to an exponent of 4 to remove the exponent 1 over 4. Then we will get w equals to 81. On the other hand, this equation we say that's invalid because we know it is not possible for a number to multiply itself 4 times to get a product of a negative value, which is -1 here. Therefore, W is 81. Example 7. Let's work on an application. The height, length, and the width of a small box are consecutive odd integers, with the height being the smallest of the 3 dimensions. Find the dimensions of the original small box if the volume of the box is 105 centimeter cube. Since we know the height is the smallest of the 3, so we're going to say that x represents the height of the box in centimeter. And we know the relationship between the height and length and the width are consecutive odd integers. For example, it could be 3, 5, and 7. So we know from the smallest number to go to the next one, we have to add 2. And go to the next one, we have to add another 2. So this implies our width will be x plus 2 and our length will be x plus 4. We know the volume of a box is length times by the width times by the height. Now, let's substitute the variables that we have into the equation, and we're going to expand the first 2 brackets and simplify it and multiply by another x, which is the height. Now we get the volume equals x cubed plus 6x squared plus 8x. Given the volume of the box is 105, so let's replace the v with 105. And then we're going to subtract 105 on both sides to make sure we have a 0 on one side of the equation before we can solve it. In order to solve for this equation, we have to use Factor theorem. So let's define our P and Q. P is our constant, -105. Q is the leading coefficient, which is a 1. Now, let's find the factors of P. And then we're going to find factors of Q. So we know all the possible values for factors is P over Q. Then we're going to substitute into the function fx to see which one can give us a remainder of 0. So we try fi1 and fi-1. Both of them are not 0. So we try fi3, which is a 0. So we know x minus 3 is a factor. Once we get a factor, then we use synthetic division to divide it. So we can rewrite the equation as divisor x minus 3 times by the quotient, x squared plus 9x plus 35 equals 0. So now we know x minus 3 could be 0, means x could be 3, or x squared plus 9x plus 35 equals 0. Then we use quadratic formula to solve for x. We can see inside the square root there is a negative value. That means this x value is not real. Therefore, we say it's invalid. Therefore, we use x equals 3 to find our width, which is 5, and to find our length, which is 7. Therefore, let's make a conclusion. The dimension equals the length times by the width times by the height. So it's 3 times by 5 times by 7. However, we will write it the other way around because we want to make sure the height is the last term. Example 8. A regular box for packaging chocolates is to be made from a rectangular piece of cardboard, 30 centimeters by 24 centimeters. The cardboard is folded according to the figure shown below. If the box is to have a capacity of 648 centimeter cube, determine the value of x. Let's use the diagram to help us to find the length, width, and height. So we know this much represents the length. So we know x plus L plus x plus L equals to 30. Then we simplified it. We divided by 2. We get x plus L equals to 15. So we know length equals to 15 minus x. Next, let's define our width. So we know x plus w plus x will become 24. That's simplified it. Then we know w equals to 24 minus 2x. Lastly, we define our height. Our height is just simply x. Once again, we know the volume of the box is length times by the width times by the height. Let's substitute our variables in and expand the first 2 brackets, and then we multiply a x and simplify it. Given the capacity is 648, which represents our volume, so we substitute 648 into V, And we subtract 648 on both sides to make sure we have a 0 on one side of the equation before we can solve it. Before we use factor theorem, it will be easier if we do common factor first. So we common factor out the 2, and then we use the factor theorem to factor them. So we try different numbers in, and we see f at 3 equals 0. Then we know x minus 3 is a factor. Now we use synthetic division to divide it, and we will get x minus 3 times by x squared minus 24x plus 108. This is the quadratic trinomial, so we factor down further into x minus 18 times by x minus 6. Now we know x minus 3 could be 0, means x could be 3. Then we substitute back into the length and the width and the height to find it. So length will be 15 minus x, which will be 12. Width will be 24 minus 2x, which will be 18. And the height will be just x, which is 3. Or we could say x minus 18 equals 0 means x equals 18. However, as you can see, the length will be 15 minus x will be negative 3. This is invalid, as the dimension of the box cannot be negative. Then we know x minus 6 can be 0. That means x could be 6. Let's try length, width, and height again. Length will be 15 minus x, which is 9. Width will be 24 minus 2x, which will be 12. Height will be 6. So now we see there are two different possible values for x. X could be 3 centimeters or x could be 6 centimeters.